Hi everyone, today I'm going to be teaching you about Pandas, which apart from being an awesome animal, is one of the most popular Python libraries that there is out there. Pandas is used for data analysis, and as data is the lifeblood of AI and machine learning, it is one of the most popular and useful Python packages that there is out there. In this tutorial, we're going to take a short, sweet, and thorough time breaking down Pandas if you're an absolute beginner. And after this tutorial, you should be able to dominate the basic parts of Pandas for your next Python projects. So let's jump into it. And as with any of my tutorials, I want you to go to Google Colab. And you can do this by going to colab.research.google.com or Googling Google Colab. So I'm going to do so here. You can go to Google Colab and you can start a new notebook here, for example. And this is going to be like the Google Docs equivalent, but for writing your Python code. I'm just going to make this a little bit bigger, and up here I'm going to title this Pandas tutorial. And you'll have these things called cells where you can write your Python code and run it. So the first thing I'm going to do in this Pandas tutorial is I'm going to start with a hashtag. This is how we write comments, just like you do in Twitter. So you do #1, and I'm going to write intro and setup. So the first thing that we want to do of using Pandas is actually importing it. And you can do this in Google Colab, which is this code runner. If I do pip install, and then I'm going to install two packages, which is Pandas. So this is how we install the Pandas package, so we can use it later. And I'm also going to install a very popular package called matplotlib. So this is what we use for a lot of data analysis and a lot of graphs and charts. So Pandas is going to be the tool that we use in order to work with data. So if we have big amounts of data in a table, we want to do operations on it. That's what Pandas is for. If we want to do graphing and charting, matplotlib is the way to go. So now you can do things like import pandas as PD. So what I'm doing here is, now that I've installed it, I want to use it. So I can do so by importing it and assigning it the simpler name, so it'll be shorter to call it in future. And I'm going to do the same with matplotlib. And here you can see it's being suggested. So I'll do matplotlib.pyplot as PLT. So there we go. The last thing I'm going to do here is I'm actually going to install or download a specific, file or data that I want to use for this tutorial. And if you're a Pokemon fan, you're going to be in luck. Here for the start, I'm going to do wget. This is typically how you call a URL or how you can use it. I'm going to do -o, and then I'm going to write pokemon.csv. This is what I want to name this file when I download it locally. Okay, and so now what I'm going to do is I'm going to open up a new tab, and I'm going to write the following: armgiles Pokemon. So you can write it like this. And we're going to download this Pokemon dataset. So if you like Pokemons, you're in luck. We're going to be using this Pokemon dataset to learn Pandas. So as you can see here, we have the names of the different Pokemons, their type 2, their total, attack, defense, all of these types of stats. And the way that we can use this is we're going to click this button that says raw. And once we get to this URL, this is what we're going to copy. And we're going to put some quote marks here and paste it in. So that's how we run it. And now if I run this all together, it should install all of the packages here and also download this data set. And so here you see it's downloaded 100%. Cool. So now let's get into the next part, which is how do we actually start using this data set with Pandas? So I'm going to do a comment here, and I'm going to say to load and inspect the data. So if I do something like df, so in Pandas, what we call a table when we load it into Pandas, so like the equivalent of an Excel spreadsheet or a table in Pandas, we call it a data frame. So typically when we load in a table, we call it df, data frame. You can call this variable whatever you want if you want. You can call it data frame, etc. But the convention is to write df for data frame. So I'm going to write df equals PD. So that's what we call Pandas, because here we imported Pandas as PD. You can import it with whatever name you want. And I'm going to do read_CSV and I'm going to import that Pokemon file. So pokemon.csv. And what I'm going to do next is you can then, if I run this, nothing will happen because, well, it will import it here, but I won't be able to see anything. So I'm going to do print df, which will print this out. And here we can see all of that table that it's loaded into Pandas. So there we go. That's how you load a table. That's how you load data into Pandas. You can do pd.read CSV if you're reading it in this format, and you can print out the table data. But this is pretty long, and as you can see, it has ... and it doesn't show me everything. So what you can actually do is you can print the first 5 rows by doing, instead of just printing the whole data frame, I can write .head like this, and you can write a number here for the first X amount of rows, right? So I'm going to print head here, and it's given me the first 5 rows here. So 1, 2, 3, 4, and 5. And if I want to do 6 rows, I can do that. And there we go, a 6th row as well. So that is a function that's quite popular. If you want to visualize what your data looks like, you can do df.head and then put a number here. So that's the first thing I wanted to show you. The next thing that you can do apart from head is that you can also print the information that you want to see from this data set. So I'm just going to print it in front of here so that you can see it a little bit clearer. So if I do df.info, we're going to start to print the information behind this data set. So if I comment this line out and I run this, here you get all of the info. So it starts to say, okay, you have 800 entries. Here are your columns, and all of your columns here are numbered. So first you have this hashtag, then you have the name, then you have the first type, the second type. This is all of the information that's part of this data set here. So the number, the name, the type. And so I can start to see all of these columns. I can start to see the type. So it says this one is a number, this one is an object, this one is a number, and here is the amount of non-null values, so the non-empty values. You can see here for this type 2, there are some empty values. So there might be some Pokemon that don't have this type 2. But generally you can use this .info function for a data frame to understand the summary of what's going on in that data set. And the last thing that I'll show you here is, I'll comment this out, but you can use this function, is what if I want to know the dimensions of my data set? What you can do is print df.shape. So .shape will give you the dimensions of your data set. So how much rows do I have? How much columns? If I print this out, it gives 813. This means that there's 800 rows. That's 800 Pokemon and 13 different columns. And so these 13 columns are these ones going from left to right here. So that's how you can get all of the basic information in Pandas. And why this is so useful is, imagine loading in typical Python all of this information. You wouldn't have these handy functions that allow you to see all this information. You'd have to code them from scratch, which is quite a pain if you'd have to do it every time. So I'll just run this cell and it gives me all of this neat information that I can use later. Cool. Now we'll jump into the next part of using Pandas. So I'll do 3 here, and I'll write selecting specific columns in a data frame. So let's say that you have all of this information, right? But you say, hey, I want a very specific type of column or information out of all of this Pokemon data set. So what you can start to do, for example, is if I want to grab things by HP, so HP is like I can't remember what it stands for, but the health points, I guess that's what it might stand for, of the Pokemon. I can write something like HP _ series. So this is a variable name. You can write whatever you want here. And if you want to get just the full column of just this HP data, so if I want just this column of HP, what I can do is I can say data frame, and I do square brackets, and then HP. This is what we call indexing. So this is how you pull out a very specific column out of a wider data frame to say, hey, there's 13 columns, but I really only want this HP one right here. So HP series is all of the data on the HP that I've now extracted into this variable. And for example, I can then print out the first, so if I get these HP series and I use that .head function that I showed you before, and I do print this out, Oh, I misspelled HP. It's in caps. So make sure that you read that because here it was in capitals. So if I now run this, it'll give me the first 5 rows, because that's what .head does, of this HP column, which is 45, 60, 80 HP, 80, 39, right? So that's how you extract very specific column information. If I don't want to do the .head and I want to print everything out, here you can see all of the data. So it goes from 0 to the 800th Pokemon over here, and it gives me all of the HP. So that's how you can extract specific columns if you want to be able to do that. I'll comment this piece out, but just for reference, that's how you extract it. And let's say that I want to extract other specific columns. I don't want to extract one because, hey, this was useful. I wanted to know the HPs, but I also want to know what the name of that Pokemon is, right? If I have the HPs. So a way that you can do that is you can make a subset data frame. So I'm just putting a variable name here. But if I want to create different data frames based on this big Pokemon one, I can write subset df equals, and then you can do the same thing that you did here with HP. So df HP, but instead I'm going to write an additional square brackets here into the HP, like you can see here. And I'm going to write other columns here as well. So I'm going to write name in quote marks and then comma separated. If you see what I did there, instead of HP, I write another square brackets and I start to write other fields. So I can say attack, defense, HP. Oh. And so now I've run it there. But if I want to print this, I can just print subset df and I run this. And here you get only those specific fields. It's removed all of the other ones, but I get just the column of stuff I want, which is the name, the attack, the defense, and the HP. And this is how you can start to manipulate these data frames to get the exact information that you may want. So that's how you select columns. Now you might say, hey, we have all these columns, but let's say I only want Pokemons with a very specific type of information. I'm going to go in here, for example, just remove this HP part and just run it so you can see name, attack, defense. But is this fourth part, I'm going to say, how do you actually filter rows, right? So if I want not 800, but I only want the specific Pokemon that do a specific thing, what I might say is, hey, I only want fire Pokemon. So I write fire Pokemon equals df, so that data frame, and we'll do those square brackets like we did up here. And we're going to, now it's actually a really interesting way of doing this. I'm going to write again df, and you're like, what's going on? This is starting to call itself, but just trust me here. And we're going to do square brackets again, and we're going to write quote marks type 1. So if you remember, type 1 is the type of the Pokemon. So here I had, for example, grass, fire. So we want to extract just the fire ones. So we say, give me a data frame, but where the data frame type 1 equals, and then we're going to write fire. So what this does is say, hey, I want your original data frame with all the data, but filter it so that the type 1 column is fire. And this is how it's going to go through each one and only extract the ones that have the fire type. So here, if I do fire Pokemon, and now I print fire Pokemon, and I run this, here you can see all of the data, but it's only extracted the fire types. You see type 1 is fire, fire, fire. If I go on the left, you can actually see how the numbers change, because I don't get the 1, 2, and 3, because those weren't fire types. If I go up here, Bulbasaur, Ivysaur, Venusaur, and Venusaur Mega weren't fire types, but I instead get all of the fire types, 4, 5, 6, and here you can see I got the 4th, the 5, the 6, so it starts to be able to filter all of this data. So I can even do .head here to get the first 5 rows, and here you can see the first 5 rows. I can also do .info, right? So if I do .info, like I told you before, it tells me I have 52 entries. So this is how I get all of the info, and now I know that there's 52 fire type Pokemons because I filtered this data set, and the size of this filtered data set is 52 entries. So there you go. That's how you filter. And if I wanted to do the equivalent and said, hey, I want to do fire or flying types, what you can do here is I can add another condition. And in Python, to say or, like one thing or the other, you can use this this line. I don't know the exact name of this, but if I wanted to do that, I allow fire or air types, what I can do is that I can write, flying types. I can copy paste this here, and instead of writing fire here, I can write flying. So if I now change this variable and said fire or flying Pokemon, and I put this here, if I run this, it's now not working. So what I want to do is I put these in circular brackets like this. And there we go. So I just have to put them in circular brackets so it fully understands this or sign. If I run this, it'll give me 56 entries. And that means that there was 4 additional flying types. So if I instead print this whole thing, you should be able to see both flying types and fire types. So here I can see fire, 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 but there's also these flying ones, like this Tornadus one. There is this Noibat, Noivern. So we see that there's actually a lot more fire types than flying types, but this is how we start to accumulate a couple of filters. You can use this or sign and this filtering technique to start to accumulate several of these together. So that's how you do the filtering technique. Next, what we're going to start to do is that we also use pandas to clean stuff up. One thing you'll find is that data that you use for machine learning, a lot of the time is spent in just cleaning it up. So I'm going to do here for our 5th one, cleaning missing values. Because you'll have values that are broken, that are missing. And so what we're going to write is we're going to write missing type 2. As we saw before, we saw that there was some empty spaces because not all Pokemons have type 2s. So we can write missing type 2 equals, and we can write df, and here we put type 2. What this gives us is the full column here, and we write dot is na. So na is the way that you find if something is empty. So you say, hey, go to this, give me this filtered version of the data frame of this sheet or this table with all of the type 2 data. And if the value, the row within there is empty, is NA, like these ones, then what I want you to do is give me the true, say that it's true, and then sum these all up. So now what I can do is I can print this amount of missing values. And if I run this, it'll give me 386. And this means that there are 386 Pokemon that are missing this value, because it's grabbed all of this type 2, it said, is it empty? And sum all of the instances which are empty. So that's how we can be able to see that. Now, there's many ways that we can start to actually fill these values. In traditional machine learning, you can, for example, one option is I'm going to grab this data set by doing df.type2, and I can say df.type2 equals, and then I'm going to say df.type2 fill na, so these empty values fill with, for example, none, right? And so now if I go ahead and I print df again, and I comment this one out, what you can start to do is it's going to replace these empty values with na. So if I run this, here you get the full list, but now it says none instead of being empty. What this means is if I copy this line that was checking for the amount of missing values, let me uncomment this again, and I paste it here afterward, I'll comment this one out, it will no longer detect these missing values because we now have replaced the missing values with none. So if I run this, it'll say 0 missing values because we've gone here and replaced all the missing values with none. So that is one technique that you can use to do this. If I use another technique, I can also be able to drop the rows. So one thing that sometimes you can do is you can say, hey, if I don't like these values and I want to just remove it because the type 2 is really important to me, what I can start to do, and I'll just comment these out, is I can do df clean, so a cleaned version of this equals df dot drop NA. So this means drop all of the values that are empty. And the way that we can do that is we can say, hey, not all of the columns are going to be empty, but we're going to write subset equals type 2, like this, in square brackets. What we did before was that we replaced all of these none values, these NA values, with actually the word NONE, right? So what we're going to do here is we can say df equals df.replace, and what we're going to do is we're going to replace these none values with the actual none values again. So if I run this, here you'll see that what it's done is it's replaced it to what it was before. But this line now removes all of those empty values. So if I see here, it's now 414 entries. And the reason is that we've removed here all of the rows where there was an empty value here. So this can also come in handy if you really need clean data. Sometimes in machine learning, people just remove the empty values. So that's also one way that you can do it. But here is how you've learned to deal with the empty values, and here how you can replace them with two techniques, either with another value or you can drop them. So that's how you clean up for the missing values. Now we're going to get into grouping and aggregation. I'm going to write here 6, grouping and aggregation. So how you can do this is quite simply. If I want to, for example, group different types of attacks, I can write attack by type is a variable, and I write here, and you can put in this braces here, or these brackets, and I can do df, so data frame, group by, this is the function to group things together, and I can say I want to group them by type 1, so put all of the type 1 Pokemon together, and grab the attack column. So all of these Pokemon together, I want you to get the attack. And then I can do things in Pandas, which would usually be more complicated in Python. Like I want to grab the mean, right? So what is the middle value of all of these? Well, the average of all of these values together. Then I can do dot sort values and write ascending here is false. There we go. And if I just run this together, what I'm saying here is, hey, I want you to get all of the Pokemon that have, and group them by type 1. So put all the fire Pokemon together, put all the flying Pokemon together, put all the grass Pokemon together. And then I want you to take the attack values that they all have and average them so that I have an average of the attack level by type, because I want to know what type of Pokemon have the best attack. Is it the fire ones, is it the blue ones, is it the water ones, etc. So now if I print attack by type, it'll tell me what the best type is. So here we see on average the dragon, because I did ascending here, the dragon types actually have the best attack. The fighting ones then have the best attack, then the ground ones and the rock ones. And if I then change this to defense and run it again, I can see the steel and the rock types, but also the dragon types have the best defense. So it could be that these dragon types are of the strongest because they keep coming up. So that's how we do grouping. If I now do another one and I do hashtag as the second one, let's do a quick visualization. What you can use is this library I said called matplotlib. So you can start to do attack underscore by type dot plot, and you can say kind is bar. So let's do a bar chart plot, as you can see here, and I'll do a title, plt.title, and I'll say average attack by type, and I'll do plt.xlabel is the type 1, and plt.ylabel, so the y-axis of this chart is average attack. And here you can do plt.tight layout. This is how you make the layout a little bit narrower. And then plt.show. So if I run this, I'll get a nice chart here saying the average, the attack type by each type. And we see here the dragon type has the best attack, then the fighting, then ground, then rock, and the fairy type is probably one of the weakest. And if I go back here and I change this to defense, you can change the names here to defense as well. But if I run this and then run this again, It'll say attack here, but it's just because I haven't changed here the names. So I can change this to defense. And there you go. You see that the steel type is the strongest in defense, then it's rock, dragon, ground, and normal has the lowest defense. So that's how you can start filtering them. And is the last few parts that I'll show you here. If I go to 8, I can show you how to export and wrap up. And so the way that you can do this is you can actually export this. So if I do, for example, I want to export this defense by type. I can do defense by type .to_CSV, and I can export this new data set that I've done here in a table format, and it can download it. So here, if I run this, I have to run this one as well. Defense by type is not defined, so maybe I just have to run it here. So if I run these two, there we go, and I'll run this again, and now it's downloaded it locally. So if I go here into the folders, I can see this defense by type, and I can actually download this file that I've created new. So there it goes. It's right here. And it's quite cool what you can start to do. If I want to, for example, plot the top values, for example, I can go here and top 50 Pokemon. I can write something like top 50 equals the data frame, and you can use the sort values function to say, hey, I want to sort you by attack, and ascending is false, so it means it starts with the highest value. And then what I want to do is, with that function that I said is head, I can actually chip off the first 50 best Pokemon. I don't want you to give me all of the 800 Pokemon. So I can now plot this, and I do plt.figure, fig size, so this is how big I want this plot to be, and I can do 12 and 8. And I forgot a equal sign there. I can do plt.bar h, so the bars, and I can write top 50, and here I write the name. And then I want to also plot, so here we can write the name, and I'll write here this -1, the colon -1, and then here I write top 50 attack. And then I write also this -1. And then you can write the title to say top 50 Pokemon by attack. The X label is attack, and here name. So I just auto-completed that because it did it really nicely for me. And I can do plt.titleAuto and plt.show. So now if I run this, it'll give me a chart of the best Pokemon by attack. I'm not sure if you can see that way over here. And it says that the number 1 is Mewtwo Mega, then it's Heracross Mega, then Deoxys Attack, then Rayquaza, etc. And so here you can start to get the top 50 Pokemon, and it starts to be above 175 as attack, which is really big. And if I wanted to just change this quite easily, I could easily do this for defense as well. So if I do defense, and I write these both here, it'll do the best by the defense. And here it's Aggron Mega, which has a defense of above 200, which is really good. So there you go. What we've done this tutorial is I've shown you how to install Pandas. I've showed you how to load and inspect CSVs. So for example, Excel spreadsheets that you can use, how to use the shape info and head functions to inspect the data. I've shown you how to extract specific columns here and make smaller subsets of the data set, how to filter the rows across various filters, how to clean up missing values, how to group and aggregate these together if you wanted to, how to visualize it in a chart, how to then export this, and then also how to sort and then plot. So there you go. Hopefully that was helpful. If you enjoyed this video and this video added value, I'd really, really appreciate if you could drop a comment below. I'm trying to improve these videos and make topics that people find useful. So please drop a comment as to what kind of video provides the most value to you or you want to see next. Thanks again, and have a good rest of the day.